Hello everyone, welcome to PW. Good afternoon everyone. Please let me know by writing in the comment section whether audio and video everything is perfect or not. एक बार जल्दी से please let me know by writing in the comment section whether audio and video everything is perfect or not. So this session is live and I'm going to discuss all the questions, my super 20 questions with you, and this will help you a lot in your preparation. Okay, so without without going to lose any 1 minute, I am moving towards the question. Okay, please observe here. Today I am going to discuss about the transformer in these 20 questions, DC machine, induction machine, as well as synchronous machine. Please let me know by writing in the comment section whether audio and video everything is perfect or not. So the first question is in front of you. What you have to do already, you have keep your calculator ready and you need to write your best possible option in the comment section. Okay, and I am going to solve as well. So first giving you 30 seconds to read the question and then I am going to start. So please go and read this question. Be ready with your calculator. Be ready with your calculator. Three-phase induction machine has 4-pole star-connected stator winding, runs on 400 volt 50 hertz supply. The rotor resistance is 0.1 ohm and reactance is 0.9 ohm. The stator to rotor turn ratio is 1.75 and rated slip is 5%. The value of maximum torque corresponding and the corresponding speed will be. So how to solve this question? Very easy, sir. How to solve this question? Very easy, sir. First of all, we need to find the speed, corresponding speed at which torque is maximum. For finding speed at which torque is maximum, we need to find slip at which torque is maximum. We all know slip at which torque is maximum is R2 dash by X2 dash. However, we need not to refer it because already rotor resistance, you can even write it in terms of R2 by X2 because both are going to be multiplied by A only. So this will become 0.9 by 0.1. Is it okay? 0.9 is the reactance and 0.1 is your resistance. R2 by X2, 1 by 0.9. 1 by 0.1 by 0.9. So you have a speed as well. NS is 120 F by P, 120 into 50. This machine is designed with 4 poles, so 1500. 1 minus 0.1 by 0.9. You can calculate, this will be equals to 113, some 3 RPM roundabout. And next is you need to find the value of maximum torque. How to calculate maximum torque? Sir, we all know maximum torque is defined as 3 by 2 omega Sm into V square by X2 dash into X2 dash. On neglecting stator impedances, since the stator impedances are not given, no information is given related to the stator impedances, so we have to choose this only. Now please observe, this is 3 by 2 omega Sm is 4 pi F by P. This machine is designed with 4 pole. Per phase voltages, since the machine is star connected, so the voltage given is a line voltage and we have to choose a phase voltage. 400 by root 3 square divided by X2 dash. We have X2, we need to refer it to the stator side. So when you have to refer it to the stator side, need to multiply with A square, where A is a stator to rotor turn ratio. Okay. Now you can easily calculate. Just we need to go through the calculator or calculation part only. Rest, it is very easy. So which one you are getting as an option? Audio, video clear? Great. So which one you are getting as an option? 400 by root 3 divided by 1.75 square into 0.9 and 12 by 8 by pi by 50. So 400 by root 3 square of the answer. .77 Newton meter. So among the following, which one is correct? 184.77. Approximately this one, because rest are far away from the possible values. How many of you able to understand this? So see, even the exact answer is not matched, but if you, we all know that these kind of have some kind of approximation in the calculation. So accordingly the options are given and you have to choose the best possible option. So in this, B is the best possible answer. Now let's come to the next question. Let me know if you have any difficulty with the question. Okay, please go through the question once. The maximum efficiency of 100 kVA single phase transformer is 98% and occurs at 80% of full load, 0.8 power factor lag. If the leakage impedance of the transformer is 6%, then voltage regulation at rated load 0.8 power factor lead will be. Okay, so how to solve this? Very easy, sir. Because maximum efficiency is given, we all know that in case of maximum efficiency, x square PSU FL is equals to PI is equals to 1 by 2 into x into KVA rated. This will give you the KVA at which efficiency is maximum. X into S rated will give you KVA at which efficiency is maximum, into cos of phi 2 into 1 upon maximum efficiency minus 1. Many times I told you how to calculate R per unit from the maximum efficiency condition. Okay, so here you have to calculate R per unit first, because once you have R per unit, Z per unit is already given to you, you can calculate X per unit in voltage regulation. So R per unit is equals to full load copper loss. We all know R per unit is full load copper loss upon S rated. From here one can write, sir, PI by X square upon S rated we can write. And what is PI? PI is this. So 0.5 into X into S rated into cos of phi 2, okay, into 1 upon maximum efficiency minus 1. Please observe, divided by X square times of S rated. We all can see that this S rated and S rated will get cancelled. This X and X will get cancelled. Is it okay? Yes, sir. So very easy one now, sir. Power factor is also 0.8. Power factor is at 0.8 lag, maximum efficiency occurs. So cos phi is 0.8. X is 80% of full load, that is also going to be cancelled out. So this will be 0.5 into 0.8 is your power factor at which if maximum efficiency occurs. The loading at which efficiency maximum is 0.8 upon 0.98 minus 1. So now you can do the calculation for R per unit. 1 divided by 0.98 minus 1 into 0.5. So 0.01, 02, 04, 08 and so on. Once you have X per unit, Z per unit, you can calculate X per unit as Z per unit square minus R per unit square. So 0.06 square minus answer square root over of answer is 0.05912 per unit. And now you know about the voltage regulation as well. What is voltage regulation? Sir, voltage regulation is R per unit cos of phi 2. Okay. Voltage regulation is R per unit cos of phi 2 plus minus X per unit sine of phi 2. Plus is for the lagging power factor and minus is for the leading power factor. 0.01020408 into 0.8 minus of 0.0591 into 0.6. So this will be minus 0.0273 and percentage voltage regulation will become minus of 2.73%. So you have to use the negative as well while typing. How many of you have given this correctly? Okay. I'm not getting any answer from anyone. Why, beta ji? Okay. So let's move to the next one. Please observe this question. Please observe this question. Please observe with this question and try to answer it. Try to answer it. Okay. Giving you 30 seconds to read, to go through the question, and then we will. Okay, great. Kevin Patel, very good. Now please go through this question. 440 volt by 220 volt transformers are operated in parallel. Two 440 volt by 220 volt transformers are operated in parallel to share a load of 125 kVA at 0.8 power factor lag. The transformers are rated as 100 kVA, 0.8% resistance, 6% reactance, and 50 kVA, 1% resistance and 5% reactance. Find the active power load carried by transformer B. Round off up to the 2 decimal digit. So very easy. First of all, you have to choose the common base. Okay. So let common base. I am assuming let common base S base as 100 kVA. So if we select any one of the transformer as a common base, so this is your S base, not SB, it's S base. Okay. So ZA will remain same. So I am saying this to be transformer A as mentioned. So ZA is 0.8 plus of J, 0.8 plus of J 6%. However, ZB will become new value, and ZB new value will become 1 plus J5. It is in percentage multiplied by new MVA upon old MVA. So 2 plus J10 it will become. Now you can calculate load kVA is given to you. Load kVA is 125 kVA at an angle upon ZA plus ZB, where ZA and ZB must be. Is it okay? Yes, sir. So now when we put the values, it will become SB will become 125 at an angle of 125 at an angle of cos inverse 0.8. Okay. So this is 100 plus J75. If you are going to multiply 125 with cos 5.8 minus of J sin 5 plus of J sin 5.6. Okay. So it will become 100 plus J75 multiplied by your value is 1 plus 0.8 plus of 6i. ZB is 2 plus 10i. So you will get 36 conjugate we need to put here. Okay, otherwise the formula is not going to be valid. So its conjugate will be negative. Oh, So I did a mistake a little bit. Somehow I need not to use the rubber, but I have used, so no issue. The question is here only, but the option is, answer is now in the next page. Okay. So it is 36.09 plus of J 29.44. Kilowatt asked for the, this is in kilowatt because that previous this was in kVA. So kilowatt is this is asked in kilowatt, so 36.09 kilowatt only. Okay, so which one is correct? We have to find out the value. Okay, so answer is 36.098. Kindly observe the calculation once again on your side. 66.27. No, beta. I think you haven't calculated by changing the base. We must need to choose the common base. If you are going with the same base, your answer is not correct. Even this is also given that you have to find out for transformer B. You have to find out for 50 kVA transformer. Maybe you have calculated for transformer A. So you need to do the calculation once again. Kevin, how many of you able to understand this part perfectly? Please let me know by writing in the comment section, beta ji. Kevin, is it okay? Great. So 38.09 or it may be 38.09 it is coming. Okay. This is 38.3717 plus of J 26.409 is coming. So you have to choose 38.37 kilowatt. Okay. So kindly check the calculation. I have done recalculation, so it is okay. So this is 37. This is 38.371 kilowatt. Can we move to the next question? Okay. So let's go with this one. Let's go with this one. Always remember, in case if the parallel operation, there is a very high chances this year they may ask some question from the parallel operation. So if the question is from the parallel operation, always remember you need to convert on common base while calculating the kVA or kilowatt shared by each of the transformer. And one more thing, always remember that in case if they ask about per unit impedances for proportional load sharing, so then that must be on the same on their own base values. Per unit impedances must be on their own base values. Okay, I have kept it in the later on questions. Please go through this one. One of the very good question. Okay, it's a very good type of question. Please go through this. 230 volt DC shunt motor has RA 0.4 ohm, RF 115 ohm. Motor takes 20 ampere driving constant torque load at 800 rpm. If the speed need to increase to 1000 rpm by weakening of the field, by increasing the resistance in the field circuit, then find the value of extra resistance to be inserted in the field circuit in ohms. Assume the magnetic circuit to be straight line, round off up to the 2 decimal digit. Very easy. How to solve this, sir? First of all, always remember about the shunt shunt motor electrical model. Okay, so that must be in your mind. RA, EA, RF values are given to you, and voltage V. Now, whenever you have to solve any question related with a speed change, always first use torque expression to find the value of new armature current and then put into the speed expression. Okay, this is the thumb rule to solve any question based upon the DC machine. So the first thing is speed need to increase, and what is the nature of the load torque? Constant torque load. electromagnetic torque must be equals to load torque under steady state condition. So from here we have torque to be constant, and torque is basically K dash phi into Ia, that is going to be constant. Since we are changing the field current, so it means Ia phi into Ia is going to be constant. So if phi into Ia is constant, then you can say Ia2 by Ia1 will become phi 1 by phi 2 by phi 1 by phi 2. Let it be x. So from here we have Ia2 to be equals to I1 is given to you. Please observe a motor takes 20 ampere while driving. Torque 20 ampere is the current taken by onto the load side. So this current will be field current. Field current is 115 and 230. So that indicates 2 ampere. Is it okay? Now if this is 2 ampere, then this will become 18 ampere. So you have to choose the armature current as 18 here now. Okay, mostly student put 20. You need to be remember here the electrical model in a well way. Sir, taking flux ratio as x. Yes, I am taking the flux ratio as x. First of all, what you have to do, always for any DC machine question, always do the same thing. For any DC motor question which is based upon the speed control, doesn't matter series, shunt or compound, always first find current from torque expression and then substitute it onto the speed expression. So I am going to move it onto the speed expression. We all know that EA is equals to K phi N, and that can be represented as V minus IA RA plus of RSC, or in case of shunt it is just RA only. Okay. In case if the brush drop is given, you have to choose the brush drop as well. So V minus IA RA upon K phi. From here you can say new speed by old speed will be equals to new voltage minus IA2 RA upon V1 minus IA1 RA. Since there is a change in the flux as well, so phi 2 and phi 1. Just we need to put the values. 1000 by new value is 1000 RPM. Speed need to increase to 1000 RPM. Previous value is 800 RPM. So we have 1000 by 800. There is no change in the armature voltage. So voltage across the armature or terminal voltage will remain 230 only. 18x into RA. RA is given to you as 0.4. So 0.4 divided by 230 minus 18. RA is 0.4. whole multiplied by x. As phi 1 by phi 2 we have considered x. Phi 1 by phi 2 we have considered x. So this equation is going to be a quadratic equation now, and we have to solve the quadratic equation to find the value of x. Okay? Yes, sir. So 18 into 0.4 is your 7.2 minus of x square plus of 230x, and minus of 230 minus 18 into 0.4 into 1000 by 800. 278.5 is equals to 0. You can choose the value of x. So x will become minus of 7.2, 230 minus of 278.5. So we have two values of x. One is 30.8, another one is 1.2606. Now please observe here, since this x is phi 1 by phi 2, and this ratio can't be such a higher value, because if you are using such a higher value means you are reducing the flux to a very lower value. We can't reduce the flux beyond 50%. Why? Because if we are reducing the flux, then at the same time armature current increases. And when armature current increases, machine will be on risk as well as losses, copper losses in the machine increases. So as far as armature current limitation, we have to choose the minimum value of the x here. So based on armature current limitation, because your flux is, armature current is inversely proportional to flux in this particular case, as pi into Ia is constant, so Ia is 1 by phi. Okay, so take x as 1.26. So if we choose x as 1.26 now, for flux to be proportional to field current, as magnetization curve is linear, given magnetization curve is linear. So since magnetization curve is linear, so new flux, new field current by old field current will become equals to 1 upon 1.26, and that will be equals to previous value is 2 ampere, so we have the new value of IF2, 2 upon 1.26. IF2 is V by RF is the old value, and now you have to identify the external resistance need to be inserted in the field circuit in order to make your speed possible. Okay, so this external resistance which need to be inserted in the field circuit I am representing here. So this R external will become 2 by V is 230 divided by 2 by 1.26 and whole minus of 115. So 230 by 2 by 1.26 minus of 115. We are getting 29.9, approximately 30 ohm. So the correct answer for this particular question is 30 ohm. How many of you able to solve this question? How many of you able to solve this question? Let me know by writing in the comment section, beta ji. Solving? Great. So actually you need not to write all these formulas and all. How you have to solve? Directly you can go with this. Okay, torque is constant, it means phi into Ia is constant. So directly you can write Ia2 to be equals to 18x. Okay, and then after writing Ia2 to be equals to 18x, next you have to put the values in this direct relation. Okay, and then you have to find the value of x. After finding x, directly you can calculate 30. Okay, how many of you able to understand this question perfectly? Great. So one of the best question. Now come to the next question. It's a kind of MSQ question. I am highlighting it's a kind of MSQ. So you have to check each of the options separately. Now see, a 400 volt 3-phase star connected, a 400 volt 3-phase star connected synchronous motor with XD 6 ohm, XQ 4 ohm running in parallel with the infinite bus, its field current is reduced to 0. Then which of the following options are correct? Which of the following options are correct? Field current is 0, it means excitation 0, EF is 0. Okay, the maximum load that can be put on the synchronous motor is 6.66 kilowatt. So with the field excitation, with the loss of field excitation, the maximum power delivered by the salient pole machine, because XD and XQ is given, is equals to the maximum reluctance power. Maximum reluctance power is at delta is equals to 45 degree. So first part you all know. How many of you able to understand? Yes sir. So let's try to solve the first part. So the first part is, option number A is you have to find the power, maximum reluctance power. Since power is VEF by XD sine delta plus of V square by 2, 1 by XQ minus 1 by XD sine 2 delta. With a loss of excitation, this will become 0 when EF is 0. Okay, yes sir, and that would be maximum at delta is equals to, so reluctance power is maximum at delta is equals to 45. So you can write V square by 2, 1 by xq minus 1 by xd. You can directly put the value. So what is V square? 400 volt. It's a line voltage, okay? So if you have to calculate 3-phase power, because it's a 3-phase motor, so you need to put 3 here. Because it's a 3-phase synchronous motor, so you need to put 3 here. This is a line voltage, okay? Yes, sir. But when you are going to put a line voltage, this root 3 square will be 3 and 3 will get cancelled out. So you can directly put 400 by root 3 square divided by 2 into 3. This root 3 square and 3 get cancelled out. So you need not to put the entire value. Then 1 by 4, 1 by 6. 1 by 4 minus 1 by 6. Just you need to calculate this. Very easy. Yes, sir. So what would be the reluctance power maximum? Maximum reluctance power. This is your reluctance power. So what would be the maximum reluctance power? 1 by 4 minus 1 by 6 into 400 square by 2. 1 by 4 minus 1 by 6 into 400 square by 2. So 6.66 kilowatt. So yes, option A is correct. Option A is correct. The maximum power that motor can operate is the maximum limit in case of loss of excitation, that is the reluctance power. Now come to the second part, armature current and corresponding to maximum power. You need to also find the armature current. Since the field current is 0, so in case of loss of excitation with the maximum power, you need to calculate armature current. Is it okay? Also you have to calculate the power factor at which maximum at maximum power condition, and power factor at maximum power condition. Okay, so what is the maximum power condition? This would be the maximum power condition. Yes, sir. Now you have to find the armature current. Please observe, we all know for a salient pole machine we need to resolve IA into ID and IQ along direct axis and quadrature axis. So if I am considering this to be the direct axis, 90 degree to the axis is quadrature axis. It's a case of motor. For a motor, we always lead EF, and EF we always get onto the quadrature axis. So this must be V. If this is your V and machine is with a loss of excitation, motor will act as a reluctance motor which works on highly lagging power factor. So current must lag highly. Yes, sir. And the excitation must be on this, excitation is onto the quadrature axis. So this angle is your load angle, that is 45 degree under maximum output power condition. Yes, sir. So you can represent V phasor, EF phasor is equals to V phasor minus of J ID XD phasor minus of J IQ XQ phasor. Yes, sir. Where ID is the component along direct axis and IQ is the component along quadrature axis, IA component along quadrature axis. So IQ is, if this is psi, IQ is IA cos psi and ID is IA sin psi. Yes, sir. Now please observe here. So V minus J ID XD would be like this. V minus J ID XD. So this must be your J ID XD. Since I am representing onto the phasor, only need to represent the magnitude, but it is definite this is ID. So minus ID is upward and minus J ID XD in the left side. So minus J ID XD and minus J IQ XQ. Since this is IQ, so minus IQ is this, and 90 degree leading to IQ will be this, because voltage drop across the inductor is 90 degree leading to the current flowing through the inductor. Is it okay? So this is IQ, so this will be minus IQ, and 90 degree to this will be minus of IQ XQ. Is it okay? So EF will be equals to 0. This is given VF is 0. When EF is 0, when EF is a 0, V phasor minus of J ID XD phasor minus of 𝐂𝐚𝐿𝑄 phasor will become 0 only. Yes, sir. Now, from the figure, it can be clearly observed that if this angle is delta, and one consider this right angle triangle, then in this right angle triangle, the perpendicular will become V cos delta, V sin delta. So, V sin delta will be equals to IQ XQ in magnitude, and from where you can calculate IQ as V is 400 by root 3 per phase voltage into sine of delta is 45 degree by XQ 4 ohm. Yes, sir. Similarly, you can calculate ID as well. V cos delta is equals to IDXD, and ID will become 400 by root 3 into cos of 45 by 6 𝐿𝑄 XD6. Okay. So, very easy, sir. This will become 400 by root 3 into sine 45. You can write sine 45 or cos 45, both the things are same only. So, divided by 4. So, this would become 40.842 divided by 6 will become 27.216 only. Now, you can calculate armature current. Armature current is equals to root over of ID square plus IQ square, because these two are 90 degree displaced. So, 40.824 square root over of answer will become 49.064 ampere. If we observe, the current under maximum output power condition is 49. However, in this it is 40. So, this answer is wrong. Now, come to the C part. The power factor at maximum power output is, you have to calculate power factor also. So, power is under root 3 VI cos phi. Since RA is neglected, there is no RA. Yes, sir. Since there is no RA, so it means whatever input power, same is going to be the developed power, and rotational losses even not given. So, you can neglect the rotational losses as well. So, you can calculate this power factor. Is it okay? Another way to calculate the power factor is, you can calculate this angle psi. Psi plus delta, and now when you know about psi plus delta, you know about the power factor. So, both of the options you can use. Is it okay? So, it is definitely a lagging power factor. I am choosing the 6.66 into 10 to the power of 3 is the maximum output power. Under root 3 times of 400 into IA, we have calculated 40.064. Okay. So, 400 into root 3, 6.66 into 10 to the power of 3 divided by answer. So, this will be 0.196 lag only. Why not lag? We are easily able to see the power factor that is lagging from the terminal voltage. Is it okay? So, lag only 0.196. 0.196. So, option number D is correct. We have to choose up to the 2 digit. So, approximately it is 1.196. How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. One of the finest question which clears you all the doubts based upon the reluctance motor and a synchronous salient pole synchronous motor. Okay. Now come to the next question. So one of the easy, since we have done some tough questions, so let's talk about one easy question as well. Consider a large transformer operating at no load draws an exciting current of 5 ampere with 120 volt 50 hertz as shown in figure. 120 volt 50 hertz as shown in figure. Okay. If iron losses are equal to 150 watt, magnetizing reactance will be. Can you solve this question? Very easy. Sir, we all know about electrical equivalent model. Sir, we all know about electrical equivalent model of a transformer under no load condition. So, this will be the electrical model. We have to calculate XM. For that, we need to calculate IM. And voltage source is given to you as 120 volt. And power entering to the machine is also given to you as 150 watt. Is it okay? So, we can calculate IC, and once we have IC, we can calculate IM, then XM. So please observe here. What is IC? IC is VOC by RC. And what is RC here? RC is VOC square POC. VOC is square by POC. So VOC upon VOC square upon POC. So from here you can write, sir, IC will be equals to POC by VOC. Very simple. So 150 by 120. Is it okay? Once you have IC, you can calculate IM. IM will become root over of I naught square, that is 5 ampere given in the question, minus of 150 by 120 square. So once you have IM, you can calculate XM. XM will become VOC by IM. That's all we need to do. So what will be the correct one? 150 by 120 square of this 5 square minus answer root over of answer divided by 120 by answer. 24.787 ohm. How many of you are able to understand this question perfectly? Easy one? Please let me know by writing in the comment section, beta ji. Power factor, Mohammed beta, Mohit Kumar, you have done incorrect while calculation, doing some calculation mistake only. So please go through the calculation again, once again. Maybe you have calculated psi. Instead of psi, you have to calculate psi plus delta in the last question. Okay. Now come to the next one. Can you solve this question? So I am creating it now. I am going to make it more interesting using a timer. Using a timer for this particular question for all of you. Okay. So creating a timer. Not more than 2 minutes is needed for this question. See, a 20 kVA 2500 by 250 volt single phase transformer has the following parameter: HV winding R1 8 ohm, X1 18 ohm, LV winding R2 0.5 ohm, X2 0.8 ohm. If the primary voltage is held constant at 2500 volt, then secondary terminal voltage at full load 0.8 power factor lagging will be. So definitely for finding the secondary terminal voltage, we have to use the voltage regulation. For that, we need to calculate X per unit and R per unit. Can you calculate X per unit and R per unit? Yes, sir. For that, first of all, we need to calculate Z base. So let's take on to the HV side. So the Z base HV side will become KV base square, that is 2.5 square upon MVA base. So 20 kVA means 0.02. So now you have Z base. If you have Z base, you can calculate R per unit. R per unit will become 8 plus of, when you refer this onto the 2500 volt side, 1000. So 100 into 0.5 divided by Z base you have to put. X per unit also you can calculate in the same way. So HV side X is 18 plus of 100 times of 0.8 divided by Z base. Z base we can calculate Z base now. So 8 plus of 100 into 0.5, 58, 2.5 square 0.02, 312.5 ohm, and 8 plus divided by answer 0.156, and this will become 18 plus 100 into 0.8 divided by 312.5, so 3.3136. Okay, once you have these two values, what happened? Once you have these two values, then secondary terminal voltage is very easy to calculate. No load voltage, we know if we apply 2500 volt, then on to the secondary side voltage is 250 minus the voltage we need to calculate under full load condition upon rated voltage is 250, because that is the rated voltage. R per unit cos phi plus of, because of lagging power factor, x per unit sin phi. How many of you able to understand this part perfectly? So we can calculate full load voltage as 2500 into 1 minus voltage regulation. So 0.6 plus 0.1856 into 0.8. Okay, 1 minus answer multiplied by 250. So we are getting 165.84 volts. How many of you able to understand this question perfectly? Let me know by writing in the comment section. Very good, beta ji. Very good, very good. So let's move to the next question. Let's move to the next question. How many of you able to understand up to this part? Great. So it's a kind of question which is a mixed with some other subject as well. It's a control system and machine, the mixture of these two. Okay. Yeah, great. Kevin, Ashish, very good beta. Mohit, very good. So you have just multiplied, you haven't subtracted. Okay, so you can do the subtraction as well. Now please observe. See, for NAT type, please, instead of going very fast, you have to be sure that you are giving correct answer. Calculation mistake is not avoided in NAT, which is highly possible that machine, one question must be in the NAT only. One question will be there in the NAT form only in the gate. Okay, it's fixed. So whenever you do the calculation, always remember NAT calculation assurance is needed. So once more is need to be recalculated. Okay. So while doing calculation, please be remember this. Consider the closed loop system for regulating the speed of a field control DC motor as shown. So we have a field control DC motor. We all can see that IA is given constant. So it's definitely a constant power type machine which gives the same IA. Okay. RA is neglected. So terminal voltage and your EMF induced power developed as well as power output is same. Okay. Under that condition, since torque is K phi IA, so torque can be controlled by phi and ultimately speed can be controlled by phi. Okay. Phi can be controlled with this, controlling this IF, which is controlled by having different voltage appeared onto the field winding. Now please observe the arrangement. So we have a motor rotor is connected to the tacho generator where the unit is given as 0.1 volt per RPM. So it means for every 1 RPM voltage generated by this tacho generator is 0.1 volt. Is it okay? And the polarity is also marked. Also the polarity of reference is marked. Is it okay? So what is the voltage appeared here? If you loop in here, the voltage appeared across this will be equals to V. Let it be V only, okay, or V only. So amplifier will be there, so it gets twised. If the motor speed only depends upon Vf, which follows a function speed n is equals to K times of Vf, where K is also given to you as 10 volt, 10 RPM per volt. It means for every 1 volt of Vf, the 10 RPM motor speed changes. Okay, so speed n is equals to KVF. Then the value of VR for maintaining the speed at 1000 rpm is? So very easy. First of all, you can observe here that is Vt, Vr and V. So with the loop voltage appeared onto the field will be, Vr minus Vt. Yes sir, Vr minus Vt. Is it okay? And now we have an amplifier. That amplifier provides a gain of 2. So 2 times this amplifier will provide a gain. So you can put K of amplifier equals to 2. Okay. And then we have field Vf. So voltage appeared onto the Vf we have. Now voltage appeared onto the Vf into K times of Vf will give you speed in rpm, where K is given to you as 10 in the question itself. That is your speed. Now this speed is being sensed by the tacho generator, and tacho generator constant is also given to you 0.1 volt per rpm. So a tacho generator generates 0.1 volt per rpm. So we have a simple arrangement of this system. If we calculate N by VR ratio, see, sometimes while solving the questions on in control system, mostly what happened, you have calculated the steady state error, and you found that steady state error cannot be directly calculated as GSHS. Okay, instead of that we have to convert it into unity feedback. The reason behind that is maybe your output is in the different format, in the different domain like speed, and input is in a different domain. You can't compare the two domains directly. So you must need to convert it into a equivalent unity feedback for finding the steady state error over here. Is it okay? So always remember that. Now let's talk about this question now. So sir, N by VR ratio will become, the forward path gain is 20 and 1 plus of loop is 20 into 0.1. Okay, so this will become 20 by 3. Now we have to calculate VR for a speed of 1000 rpm. In order to maintain the speed to 1000 rpm, so 1000 into 3 by 20. How many of you able to understand this? So how much voltages need to be applied? What is 100 beta ji? 1000 is given to you. 100, what is 100 you have calculated? Can you please let me know by writing in the comment section, beta ji, what is 100? 1000 into 3 by 20. We are getting reference voltage needed to be 150 volts only. Anish, kindly do the correction, beta. How many of you able to understand up to this part? Very good question. Okay. So let's talk about this one. Now move on to the synchronous once again. Clear? Great. So in this question, 2200 volt 3-phase star connected synchronous motor is connected to an infinite bus bar at rated voltage. The synchronous impedance is 1 plus j10 ohm per phase. If the excitation voltage is adjusted to 2800 volt for an input power of 300 kilowatt, then load angle will be in degrees. So make your calculator out. Did the mistake? Okay. See, before approaching to the question now, first think for a 30-40 seconds. Once you are reading, while reading, first try to grasp all the data. Like when I am reading, first data is the voltage is 2200 volt 3-phase is star connected, because that is important. Line or phase voltage is related to that. And then the synchronous impedance 1 plus j10 ohm. Soon I observe 1 plus j10 ohm, then Zs is in my mind under root of 1 plus 10 square 100, under root of 101. Okay, so that is done in the calculation in my mind only. If the voltage is adjusted to 2800 volt, excitation voltage means EF. EF is over excited. Okay, for an input power of 300 kilowatt. So now we have to go with the input power. Since RA is present, so VEF by sine delta is not applicable here. You need to remember the input power equation for a motor, and mostly a student forget about the input power. Okay, so hoping you also do not have remember the formula. So when you are not able to remembering the formula, start going with the conventional approach. What is the conventional approach? We all have a simple electrical model. So V, IA, yes sir, RA and JXS and EF. Okay, so sir, basically we can, if we have to calculate input power, so definitely what is input power? Input, if I am able to find kVA input power, then input active power is very easy to remember or to generate. So what is input? VIA conjugate. So what is IA here? IA is V at an angle 0 minus EF at an angle minus delta, because it's a motor, upon ZS at an angle theta S. Hoping all of you have remembered this. Yes sir. So IA is this, and you have to calculate the conjugate of this. So conjugate of this will become, including conjugate, I am calculating this kVA input. So V at an angle 0 into IA conjugate would become V by ZS at an angle of minus of theta S, and conjugate will become plus of theta S minus V EF by ZS at an angle of minus delta minus theta, and conjugate of that will become delta plus theta S. Is it okay? So even if you haven't remembered the formula, you can create. Once you have this value, then you can calculate the active power input. Active power input will become V square by ZS cos theta S minus of VEF by ZS cos delta plus theta S. Is it okay? Yes sir. Now for a per phase basis, for a 3 phase, what you have to write? Sir, for a 3 phase we can multiply by 3, and this will become 300 kilowatt is given to you. So 300 kilowatt would be will be equals to, I am not writing 3 here, because if I am write 3 and then line voltage is 2200 by root 3, square of that is square of the root 3, 3 and 3 will get cancelled out. So I am directly substituting the values of line only. 2200 is square divided by 101 cos of theta S. Can we calculate theta S? Tan inverse 10. Tan inverse 10 is 84 degree, and cos of theta S is RA by ZS. So ZS is square, it would become minus of V is 28200 into 2800 by ZS. ZS is under root of 101 cos of delta plus theta S. So you can write delta plus theta S. Theta S is 84.28. Okay. From this, the only unknown parameter is delta. You can easily calculate the value of delta now. Okay, so 300,000 into root over of 101, and if I put it on this side, it will become negative. So minus of, or 2200 square by root 101 minus of answer negative divided by 2200, 2800. Okay, cos inverse answer 114 minus 84.28. So we are getting exact value as 30 degree. How many of you able to understand to solve this question? How many of you able to understand how to solve this question? Yeah, 29.97 is okay. Okay, it is in the range. Why? Because it's depend. Someone may take in as 100 instead of taking 100 and root 1. Someone may take it as 1 plus j10, and it is will be nearly 10.04 something. So if someone have calculated as 10.04, then also it will be treated in the correct range only. Okay. So how many of you able to understand the range for that kind of question? The range for that kind of question is nearly you can write 29 to 31. Okay. So this kind of question will have that much of range, and the reason behind this is because of the approximation. Maybe someone has taken an approximation. Is it okay? Yes. Let's talk about another question. Can you solve this one? Yeah, great. Can you solve this one? I need a response from everyone. Can you solve this one? It's a MSQ question. First thing is it's a MSQ question. So it's a MSQ question. Now please observe 230 volt by 115 volt 52.9 kVA 50 hertz 3-phase transformer has the following parameter: 0.08 ohm R1, 0.02 ohm X1, 0.32 X2, 0.06, total core loss 4.232 kilowatt. Okay. If the transformer is operating at full load 0.8 power factor lag, then which of the following are correct? Per unit resistance of the transformer is very easy to calculate. The per unit resistance, start with this only. So per unit resistance would become, sir, R1 is given to you, you can calculate R2 on R1 side, and then you can take Z base. So first calculate Z base. What is Z base? Z base will become kV base square upon MVA base 0.35 0.23 square 0.23 square upon MVA base is 0.0529. Okay. So once you have Z base on HV side, you can refer the parameter on HV side and calculate R per unit. R per unit is R1 0.08. R1 is 0.08 plus of, when you put R2 on HV side, it will become twice 4 times of 0.04, because A is 230 by 115, that is equals to 2. So square of 2 is 4. Okay. And you can put the value of S base. So 0.32 ka square divided by, okay, same value only. Wow, Z base is 1 only. So Z base is 1 only. This is 8 and 8.16 per unit. Great. So A is correct. Now come to the second part. For an input voltage of 230 volts, its secondary terminal voltage across the load will be. Its secondary terminal voltage across the load will be. So definitely we are talking on the full load 0.8 power factor lag condition. So under full load 0.8 power factor lag condition, what would be the secondary voltage? You can calculate secondary voltage under full load condition as rated voltage, because you have applied rated. So onto the secondary side, rated voltage into 1 minus voltage regulation, because it's 0.8 power factor lag. So you need to calculate voltage regulation only. So 115 into 1 minus voltage regulation is R per unit cos phi plus minus X per unit sin phi. So can you calculate X per unit as well? Yes, sir. R per unit we have. Can you calculate X per unit? X per unit will become 0.32, and 4 times of this is 0.24. Okay, so 0.56. Okay, and voltage regulation will become 0.16 into 0.8 plus of 0.56 into 0.6. So this will be the voltage regulation. 0.16 into 0.8 plus of 0.56 into 0.6. How many of you able to understand this question perfectly? 1 minus voltage regulation multiplied by 115. We are getting 61. So this is wrong. I am getting voltage regulation to be So while solving this, we are getting secondary terminal voltage to be equals to 61.64. So that indicates this is wrong. Efficiency of transformer at 3/4 of full load, 0.8 power factor lag. Maximum efficiency of transformer occurs at a loading factor of 70.71. So let's talk about efficiency now. Efficiency at 3/4 of full load is 3/4 times of S rated into cos of phi 2, and we have to calculate full load efficiency at 0.8 power factor lag. So divided by 3/4 of full load into cos of phi 2 plus of pi plus of PCU FL. So one can represent 3/4 square x square PCU FL is there. So 3/4 square PCU FL. So 3/4 into 0.8 can I represent like this? 3/4 into 0.8 plus of pi. Pi is, we have pi 4.32232 4.3232 divided by S rated. S rated is, this is in kilowatt, that is in kilowatt, and this is in kVA, 52.9. So 52.9 plus of, if you represent PCU FL by S rated, so that will be equals to R per unit only, and already we have R per unit. Okay, so you can calculate efficiency at 3/4 of full load. I have just divided S rated on both upper and numerator and denominator. Okay, so 0.75 square into 0.16 plus of 4.232 by 52.9 plus of 0.75 into 0.8. 0.75 into 0.8 divided by answer. So we are getting 77.92%. However, the given answer is 86. So this is also incorrect. Come to the last one. Yes, maximum efficiency of transformer occurs at. So when the maximum efficiency occur, efficiency is maximum, the loading at which efficiency is maximum, X. The loading at which efficiency is maximum is under root of Pi by PCU FL. You can also put directly the per unit values. So 4.232 by 52.9. So this is Pi is 0.08 in per unit upon PCU FL is 0.16. You can also use this way. Is it okay? So Pi in per unit is 4.232 by 52.9, that is 0.08 only. Is it okay? Because for both your base rated is the same, huh? 1 by root 2 0.707, so 70.7%, 70.71%. So option A and D are correct. How many of you able to understand this question perfectly? Great. So now hoping all of you can solve such kind of question in a rapid way. Yeah, great. Let's talk about one more question. Can you solve this one? Giving a timer once more. So I think 1 minute is sufficient to solve this question. Please go through this. A DC generator has 8 pole 480 armature conductor is wave wound. If the generator supplies a current of 100 ampere and brush is shifted by 5 degree mechanical, the demagnetizing armature reaction will be FAR demagnetizing. FAR demagnetizing in terms of ampere turn per pole is Z by 2 by P. It means total number of conductors by 2 turn by P, turn per pole, into IA by A, that is coil current. Is it okay? Into your 2 beta electrical by 180, where beta electrical is the brush shift given. Because of the brush shifting, there would be a demagnetizing effect introduced in the DC machine. So total number of armature conductors are 480 by 2 by P. This machine is designed with 8 pole, into IA is 100 by number of parallel path for a wave wound is 2 into beta. You have to remember that beta electrical is P by 2 times of beta mechanical. So beta mechanical is given to you. What is beta mechanical given? Beta mechanical is given to you. This machine is of 8 pole. So beta mechanical is 5 degree, 20 degree. So this would become 40 by 180. Is it okay? Now you can easily calculate FAR demagnetizing. How many of you able to understand this question perfectly? 480 by 16 into 50. This would be equals to 333.33 ampere turn per pole. So that much of demagnetizing effect is introduced. Very good. Anish is going great. Let's try to solve this one. And let me know if you are unable to understand the question solution. Now let me know. I will explain. Presently I am considering that already you know and you are doing the practicing along with me. Okay. So accordingly I am just recalling with the formulas and all. But if you want explanation, ask me. I will explain each and everything as detailed as possible. There is no time bar for me. Okay. Now please observe here. The stator of a 3-phase, how much time is required to solve this question? In my opinion, time required for this question is around 30 seconds, but let's take it 1.5. Okay. So I am giving you almost 2 minutes. See, the stator of a 3-phase 4-pole AC machine has 72 slots. So number of slots are given to you 72. Okay. And stator is bound with double layer winding. So you know about double layer winding. Double layer winding. Is it okay? Yes, sir. And the winding is short pitched by 3 slots. Short pitched by 3 slots. Okay. Yes, sir. Find the number of slots having top and bottom layer belonging to different phases. So what you have to do, make 2 different clocks in your mind. Okay. One is the outer clock and one is the inner clock. Okay. Make 2 clocks in your mind. Okay. Like this. So there are 2 clocks. Oh. We have in this way number of slots are there. Okay. So there would be a one outer layer winding and one inner layer winding. Okay. One outer layer winding, one inner layer winding. In this way, the total number of slots are 72. Total number of slots are 72 in this way. Is it okay? So first of all, we have to calculate M. M is defined as number of slots per pole per phase. So you have designed a machine of 72 slots, which is designed with for 4 pole and 3 phase. Is it okay? Yes, sir. So M is equals to 6. It means for every pole, number of slots per pole per phase is equals to 6. Is it okay? Now we have 2 clocks, an outer clock and an inner clock. inner clock need to be rotated in an anti-clockwise direction with as many number of slots are there is a short pitched. So it is short pitched by 3 slots. So it means if you are going to rotate anti-clockwise by 3 slots, so what happened if these 3 slots are shifted here? Okay, 1, 2, 3. If these 3 slots are shifted here, then out of 6 slots, 1, 2, 3, 4, 5, 6, the 3 slots are belonging to different phases. Is it okay? Because the inner layer is shifted in the anti-clockwise direction. Okay, so number of slots belonging to number of slots in which top and bottom belonging to different phases. So how many number of slots are there? Total is 72. How many combinations of the 72 slots in terms of number of slots per pole per phase? So for that you have to divide it by m into, so that much of combination. Okay, and out of 6, every 3 slots are short pitched. Is it okay? Yes sir. So out of total number of slots are 72. How many possible combination of 72 slots? 6. There are 12 such combinations are possible with the 6 slots per pole per phase. So there are total 12 combinations are possible, and in every possible set of 6 slot there are 3 slots which are belonging to different phases. So just I have multiplied. Is it okay? So how many number of slots in which top and bottom layer belonging to different phases? That is 36. Hoping all of you able to understand it. Great Kevin. So that indicates you have studied in a very well way. Great. I'm very happy. Mohit, very good beta. Anish, very good. Now please come to this one. Can you solve this one? Can you solve this one? Okay, great. So such kind of easy questions will be there in your gate exam, actual gate exam as well. Okay, 1 or 2 question may be tough. Rest of the question for the machine always going to be asked easy one, or the question belonging to somehow belonging to the PYQ or some other exam in which machine has been asked. Okay, so it's already there are all possible combinations are already done. Okay, they can only play with the language, that's all. Now please observe a 3-phase delta connected. So while reading the question first time, what are the important data that you need to absorb? Okay, a 3-phase delta connected synchronous generator is rated at 100 megawatt, 0.8 power factor lagging. So rated means output power of 100 megawatt, 0.8 power factor lagging, 13.6 kV, 50 hertz, 100 rpm. If the generator full load efficiency is 97%, neglecting field copper losses, the prime mover of the alternator will have output torque of. It's a very easy one. Why? Because you know about the prime mover input torque. It's a generator. Okay, and in a generator you know about the output power of the generator. There are some rotational losses, some copper losses. Field copper loss is already neglected, which is supplied by some separate source. Okay, so that is already separated. Field copper loss is already separated. Now what is the output power we are getting? So this delta connected output power we are getting is 100 megawatt. So this is your output power. And what is your input mechanical power? So if you know about the efficiency, input mechanical power will become, since efficiency is output upon input, so efficiency is output upon input, so output upon efficiency is your input power. If you know about input power, then input power is always in terms of applied torque, and machine is rotating at omega sm. Is it okay? Yes sir. Electromagnetic torque in case of generator is in the opposite direction, and that is your developed power. So very easy sir. We can calculate input power directly. Input mechanical power to the motor is torque applied by the motor, torque applied torque input to motor, torque input to generator into torque input to generator into torque input to generator into omega Sm. Is it okay? And torque input to generator is the torque supplied by the turbine. Torque input to generator is the torque supplied by the turbine. So torque supplied by the turbine, turbine output torque is basically input torque to the generator or applied torque to the generator. So output torque of the turbine is equals to input power 100 megawatt by 0.97 is the input power to the generator. 4 pi f 50 hertz, 100 rpm is given. So rpm speed is given 2 pi n by 60. Is it okay? 2 pi n by 60. Since this speed is given in terms of speed is given in terms of 100 rpm. Is it okay? Yes, sir. So you can calculate in this way. Poles are not given, so you don't know about the frequency because the poles are not given. 100 by 0.97 divided by 2 divided by pi divided by 100 into 60. How many of you are getting 9.84 Newton megawatt? You have to calculate in terms of kilonewton meter. So this is in megawatt, 10 to the power of 6. Okay. You have to calculate in terms of 10 to the power of 3. So 100,000 by 0.97 9,844.63 kilonewton meter. How many of you are getting this answer? Great, Betaji, great. Very good. So let me know how many of you able to understand up to the part completed. Great. Can you solve this question? Can you solve this question? Try to solve this one. Try to solve this one. Sir, I have a doubt. What, Betaji? Please tell me. What doubt you have in this one? Please let me know by writing in the comment section what doubt you have. Oh, गिर गया. Sorry. What doubt you have, Betaji? Please let me know. Gate 26. What doubt you have, Betaji? Please let me know. Now please observe this question. 250 volt DC series motor has an armature current of 1 ohm, has an armature resistance of 1 ohm, field winding resistance of 0.4 ohm. So total is 1.4. Okay. Motor takes 20 ampere when while rotating certain load. If the load torque varies as a cube of the speed, if the load torque varies as a cube of the speed, then the value of extra torque, extra resistance required in series with the motor to reduce 70% of the previous value. Very good. So torque, electromagnetic torque is proportional to Ia square in case of magnetization circuit unsaturated. Yes, sir. Because basically torque is proportional to K phi Ia, and phi and Ia are proportional. So for series motor, torque is proportional to Ia square. So Ia square is proportional to N cube because electromagnetic torque is equals to load torque under steady state condition. Under steady state condition. So that will help you to calculate new armature current. So new armature current Ia2 will become 70% of the speed cube of this root over of this multiplied with 20. So now we know about the new armature current. So what is new armature current? 0.7 cube root over into 20. How many of you able to understand what I have done here? Once you have this, you can put onto the speed expression. So N2 by N1 is basically voltage we are not changing, Ia2 Ra plus Rsc plus an external resistance we are applying in series with the armature, Ia1 Ra whole multiplied by your flux phi 2 by phi 1. So this value is given to you because we have to change the speed, reduce to speed to 70%. This 2 and by word is very important. Always remember this. Now the 250 volt motor we have. New armature current, we can calculate new armature current as 0.7 cube root over of answer into 20. So 11.7132 into 1.4 plus external resistance which need to be inserted in order to reduce speed, and 20 into 1.4 whole multiplied with flux. Flux will have same as current ratio because magnetization curve is linear. So new current is 11.713, old current is 20. You can calculate external resistance from here. So this will become into 0.7 into 250 minus 20 into 1.4, okay, divided by 20. 250 minus answer 11.7132 minus 1.4. So I am getting nearly 12.1723. Can you check the calculation, beta ji, from your side? Kindly do the calculation from your side as well. Aha, 11 point, no. Anish, 11 point is the armature current. You haven't calculated the resistance. We need to calculate as extra resistance which need to be inserted in series to reduce the current. See, for all kind of speed control question, always torque will help to find the armature current and put it onto the speed expression, while always remembering that onto the speed expression when we are going to substitute, maybe the voltage is changing, maybe extra resistance will be added, may field will be changes. Okay, great. Yes, Naveen, great. Let's talk about this one. So please observe very carefully because I have kept all type of possibility that you can do, all kind of error that is possible you can perform in the exam as well. Okay, so please be careful while going through the question. The below diagram shows two winding transformer figure 1 and auto transformer figure 2 found by reconnecting the terminals of two winding transformer. The marking terminals are conventional one with regard to the respective polarity. For the same load in both condition, current in common winding of auto transformer will be. See, so first of all, the load is the same. Yes. So can we calculate the load here? Yes, sir. What is the load here? 100 into 80, that is 8 kVA. So the same load will be here as well. Because for the same load we are we need to calculate. Can you calculate this IL? If you are able to calculate this IL, can you calculate this IH? We all know that current if enters through dot, then at the same time current must leave through the dot. Yes, sir. This side also, because it's ideal transformer, so this side also it is 8 kVA. So we can calculate IH as well. What is IL? IL will be equals to 8 kVA divided by LV side L2 L1. What is the voltage across L2 L1? 100. So voltage across L2 L1 is 100. So you have to divide it by 100. So this is 80. Is it okay? And how to calculate IH? IH will become 8 kVA divided by, this is 100. Yes sir, as per the polarity is given H2. If we consider H2 L2 as same polarity, so H2 and L2, because two suffix will have same polarity and one suffix will have same polarity, already it is given in the question as well. It is marked conventional, so polarity has been marked conventionally. So plus minus voltage is going to be added. What is the voltage across H2 N1 while it is in a two winding transformer? 400. Is it okay? So 400 plus 100, that is HV side, it is 500, and now you can put 500 here. So what is the value of IH? Can you calculate IH and IL? 80 is okay. This is 8000 by 500, 16. Okay. So what is the current in the common winding? IL minus IH. So what is IL minus IH? You can write IL minus IH as 80 minus 16, 64 ampere. That's all we need to perform in this question. How many of you able to understand? Great. Very good. Great. Now come to this question. So let's talk about this one. See, everything already you know. I have just twisted the language, that's all. I have twisted the language. I have tried to keep the things so that you can rethink again and again. Like someone may done the mistake while calculating, instead of a current, may someone have calculated kVA, and for maximum kVA someone may have calculated the current in the common winding. Is it okay? But the words are very important in the question. Okay, so here the question, like it is given, you have to calculate for same load. These words are very important. Is it okay? Now come to this one. Great. A 3-phase 50 Hz 4-pole 50 kilowatt 440 volt star connected induction motor takes 3 kilowatt under no load condition. When block rotor test is conducted on rated current, it takes 4 kilowatt of input power. Rated current, it takes 4 kilowatt of input power. Assuming its stator and rotor copper losses are equal under rated load condition, rotational losses are 30% of the no load loss, then full load slip. Full load slip of the motor will be in per unit. Great. So, hoping all of you have remembered the power flow diagram. You need not to redraw. I am doing this just to recall for you. Okay. This motor is designed with 50 kilowatt. So 50 kilowatt is your output power, rated output power. Yes sir, rated power is always output power. Given that star connected induction motor takes 3 kilowatt under no load condition. What are the losses under no load condition? Core loss and rotational loss. Under no load condition, core loss and rotational loss. Okay. Further, block rotor test is conducted at rated current. So it gives rated copper loss, and it is given that neglect stator rotor copper loss during no load and core loss during block rotor test. So if I neglect stator and copper loss, it means no load loss will be equals to, core loss and rotational loss only. Yes sir. Please observe first. You know about full load copper loss. What is full load rotor copper loss? Full load rotor copper loss is 2 kilowatt. Why? Because it is given that assuming stator and rotor copper losses are equal under rated load condition, and when the block rotor test is conducted, on neglecting core loss during block rotor test, only copper loss will be there, and that copper loss at rated current is a full load copper loss. So full load copper loss we know, and 4 kilowatt is the total full load copper loss, including stator and rotor, both are equal. So copper loss onto the rotor under full load condition is 2 kilowatt. Is it okay? Yes, sir. So this 2 kilowatt is given to you from the block rotor test data. This 2 kilowatt is given to you from the block rotor test data. Total is 4 kilowatt. So under full load condition, this is also 2 kilowatt and that is also 2 kilowatt, because under block rotor condition we have a copper loss only, and copper loss occurs onto the resistances. It is given that the copper losses are equal under rated load condition. So 2 kilowatt and 2 kilowatt. Also it is given that under block rotor condition, under block rotor test, core loss is neglected. So only copper loss will be there. So this makes us sure that rotor copper loss is 2 kilowatt and stator copper loss is 2 kilowatt. Further, rotational losses are 30% of the no load loss. Rotational losses are 30% of the no load loss. Okay. Yes, sir. So what is no load loss? No load loss as per the given information is core loss and rotational loss, because during no load condition it is given that neglect stator and rotor copper losses. So only these two losses will be there. And further it is given that the rotational losses is 30% of the no load loss. It is given that rotational losses are 30% of the no load loss. So what would be your core loss? 1 minus 0.3 times of no load loss. No load input power under no load condition is 3 kilowatt. So this will become 2100 kilowatt, 2100 watt, 3 kilowatt, 2100 watt. And rotational loss would become, sir, 30% of the no load loss. 30% means 0.3 times of, so 0.3 times of this is 0.9 kilowatt. 0.9 kilowatt. 30% of no load loss, 30% of 3 kilowatt is 0.9 kilowatt. So we have PD as well, 50.9 kilowatt. And if we have PD, if we have SPG, we can calculate PG as well. So this will become 52.9 kilowatt. 52.9 kilowatt. And now you can calculate slip. Slip will become 2 upon 52.9. Okay, yani I am writing PG SPG by PG. Is it okay? So that's all we need to perform. 52.9 by, okay, 2 by 52.9. That is approximately the slip is 0.0378. Is there any option of 0.0378? Yes. How many of you able to understand this? Great. 0.0391. Okay, it will be treated correct only. There is no issue. Because 0.03 is only one option. So if you are getting 0.03, it's okay. How many of you able to understand up to this part? See how the data is given in the question. This question is very potential question. Not only a block rotor, not only a block rotor test, power flow or input power under no load condition, efficiency, everything has been checked, a rated power. So this is very potential question. Now come to the next one. Can you solve this one? Sir, why you have kept this one? So that if someone is doing all the question wrong, at least they can do some questions correct. Sir, last part samajh. Which one beta? Which one you are unable to understand? This question? Are you unable to understand this question? Gate 26, please let me know. Lot of silly mistakes. Why you are doing silly mistake is because you are underconfident while start solving the question. Please be confident. Okay, your mind is just fearful that it's a machine, so whether I am able to do or not. It's very easy. First of all, you have to win on your own. So it's a easy one. Sir, slip. Okay. See, in this question, it is given that motor is taking input power of 3 kilowatt under no load condition, and the input power under no load condition is no load losses only. In the bracket, it is given that neglect core loss under no load condition. Oh, okay. Neglect copper loss stator and rotor under no load condition. It is given. So if we neglect copper losses under no load condition, 900, 2100 watt is your loss that occurs onto the stator core. Is it okay? Okay. Next is, it is given from the block rotor test data, the input power under block rotor condition is 4 kilowatt. Under block rotor condition, if we neglect core loss, then whatever power input will be going to be dissipated across the resistances only, across the stator and rotor resistances only. So it means there will be a stator copper loss and rotor copper loss only. Since the test is conducted at rated current, so we know about the full load or rated copper loss occurring onto the stator and rotor. Also given that stator copper loss and rotor copper losses are equal. So if the total power input is 4 kilowatt and stator and rotor copper losses are equal, it means stator copper loss full load is 2 kilowatt and rotor copper loss full load is 2 kilowatt. Now rotor copper loss is the slip power. Is it okay? And full load output power is given to you. Full load output power plus rotational power, you will get developed power as 50.9 kilowatt. 50.9 kilowatt, and the power which is not converted into mechanical power, slip power, is 2 kilowatt. So the air gap power which is input to the rotor is 52.9 kilowatt. If you know about air gap power and slip power, slip will become SPG upon PG only. Is it okay? Have you able to understand now, beta ji? Okay. Now come to the this one. A 3-phase 8-pole induction motor has frequencies of stator and rotor EMFs as 40 and 2.5 hertz respectively. The motor speed is NR is equals to NS 1 minus S, and NS is 120. What is the frequency onto the stator? Stator is 40 and this machine is of 8-pole. And what is the frequency onto the rotor? Frequency onto the rotor is 40. So this will become 8 into 1 minus 2.5 by 40. How many of you able to understand this question perfectly? 2.5 by 40, 1 minus answer into 120 into 40 by 8. So 562.5 RPM. But that is not the answer. How great! No one has given this. No one has given this. Great. Answer is in radian per second. So what would be the answer in radian per second? You have to go to the omega r now. So either you can calculate omega r by 2 pi nr by 60, or another way is, why not you have opted this 4 pi f by p into 1 minus f2 by f1 to calculate directly. Is it okay? So 4 pi f is your 40 by p is 8 into 1 minus 2.5 by 40. That would be more easy. Is it okay? Yes, sir. So into 2 into pi. Into 2 into pi by 60. So what I am getting is 58.90. Acha, revolution per second. It is an RPM only, beta ji. So RPM is okay. Instead of revolution per second, if they ask in an angular, then you have to calculate. It's a RVE, so revolution per second. Okay, so this is the answer. Okay. If they ask, if I am going to change a little bit so that it will be have some better question now. So it's in a radian per second. Then you can calculate like this. Okay. So how many of you able to understand up to this part? 4 pi f by p1 minus 58.9 radian per second. So if it is in radian per second, you have to remember this. Okay, I have created this for a radian per second, but maybe there would be a typing mistake. So kindly observe it very. Yes, it's a revolution per second is RPM only. Okay, RPS, revolution per second is RPS, revolution per minute is RPM. Okay, in case of per second, you need to divide it by 60. You need to divide it by 60, then it will become rotation per second. So 562.5 by 60, then it will become 9.375 rotation or revolution per second. Now it is in RPS. Okay, so those who have given the answer 9.375 is correct, and I have now changed the question, then it will become this. Okay, those you have given the answer 9.3 is correct, beta. Bilkul, absolutely correct. Yes, yes, absolutely correct. We need to divide it for, I thought it is a radian per second, so it's a revolution per second. You have to observe the question language. I did a mistake here. Please don't do that kind of mistake in your paper. Okay, so I have explained each one, RPM, RPS or radian per second. So kindly don't do that kind of mistake. Now please observe this one. Great, great. So most of you have given the correct one. Anish, great. Kevin, great. Is it okay? Yeah, great. Now please observe here. When a single phase transformer is connected to 240 volt 50 hertz supply, the core losses is 600 watt. When the supply is reduced to 192 volt 40 hertz, the core loss is 400 watt. The value of hysteresis loss in the transformer for 240 50 hertz supply will be dash watts, round off up to the 2 decimal digit. So first of all, we need to check V by F ratio. For V by F ratio, we have 240 by 50, or you can write 192 by 40. Please observe whether V by F ratio is same or not. In case if V by F ratio constant, then we have different approach. In case if it is not constant, then we have different approach. So 240 by 50. So this is 4.8. Great. So these both V by F ratios are 4.8 and that is constant. So when V by F ratio is constant, you can calculate KE dash. KE dash is PT1 by F1 minus PT2 by F2 upon F1 minus F2. So at 50 hertz, the total loss is of 600 watt by 50 minus 400 watt by 40 divided by 10. So once we have KE dash, you can calculate KH dash, or instead of writing KH dash, you can also calculate directly PH, because if you know hysteresis loss, total loss is 600 watt. So total loss minus eddy current loss is also a hysteresis loss only. But I am calculating. Okay, so 600 by 50 minus KE dash into 50. That would give you KH dash, and hysteresis loss will become KH dash into 50. At 50 hertz, we have hysteresis loss now. So 600 by 50 minus 400 by 40 divided by 10. 0.12. Okay. 0.12 into 50. 600 by 50 minus answer is 6 only, and pH will become 300 watts. 100 watt. So where (600 by 50 minus 400 by 40 by 10). Okay, this is 0.2. Okay, okay, okay. 0.2 means this would become 600 by 50 minus 0.2 into 50. That is 2. And this would be 100. See, it doesn't matter how proficient you are, how much questions you have done in your practice. If you did any calculation mistake, then in NAT, no marks will be awarded to you. If I did that mistake and put 300, no marks will I get. There is another way to counter check also. In such kind of questions which you thought usually may the mistake happen because it's NAT, you don't know whether the answer is correct or not, then you will better to go with one more way. Like I have calculated in this way. Another one is you can have KE dash multiplied, but even if you done this KE dash calculation mistake, then doesn't matter how many times you are going, how many ways you are going, you will do wrong only. So it's a 0.2 and I did some calculator press key error, and because of that instead of 0.2 it is 0.12. Okay. However, without using calculator it will be more easier. Okay, great. Now come to the next one. Can you solve this one? Or let's first solve this one. Can you solve this one? Please observe. When a 5 kVA 400 by 100 volt transformer has a equivalent resistance and reactances referred to HV side are 0.25 ohm and 5 ohm respectively. If it supplies a lagging power factor load, then following wattmeter reading were be recorded. Meters were placed on the HV side. Okay. So supply is given on LV side and supply is given on the, when it supplies lagging power factor load, the following meter readings would be recorded. Okay, meters are on HV side only. Under this condition, the reading of voltmeter connected across the terminal, across the load terminal will be, assume the excitation current to be 0. Okay, so you have to neglect the no load current. Exciting current 0 means no load current is 0. Okay. So basically we have a supply here, and onto the supply voltmeter is placed, ammeter is placed, and a wattmeter is placed. Okay. So onto the supply, this wattmeter is reading 15 kilowatt and ammeter is reading 15 ampere, voltmeter is reading 400 volts. This we have a supply, line neutral. This supply is given to one transformer. This supply is given to one transformer, and that transformer HV side having resistances and reactances equivalent, we know. Okay. Yes, sir. Resistances and reactances equivalent, we know. Then we have ideal portion of the transformer, and onto the secondary side, it is feeding some load. That information is not given. There would be one voltmeter connected on load end to calculate this voltage as well. Is it okay? Yes, sir. So this value is, R equivalent is 0.25 ohm and X equivalent is 5 ohm. Can you find out what is the power entering to the transformer? Yes, sir, 15 kilowatt. Can you find what is the current entering into the transformer? Yes, sir. Do you know about what is the voltage input to the transformer? Yes, sir, 400 volts. This transformer is designed for 400 by 100. So definitely under loaded condition, when current will flow here, I2, some I2 dash will flow here. This I2 dash is basically calculated here as I1. Is it okay? Because I0 is neglected. So if we remove this drop, we get the voltage under loaded condition. And now when we refer this voltage on this side, we have voltage onto the secondary under loaded condition. Is it okay? Great, sir. So what would be the current? Current is 15 ampere. What is I1 or I2 dash? That is 15 ampere. And what is the power factor? Power factor, the power input is 15 kilowatt. Power is VI cos phi. So cos phi will become POC, P input power upon VI. 15 kilowatt, and we have ammeter of 15 ampere as well. So yes, sir. We know about I1 or I2 dash. If you know about I1 or I2 dash, you can calculate V2 dash. V2 dash would become V1 minus of I1 R1 plus R equivalent plus JX equivalent. This is your 400 at an angle 0 minus of I1 is 15 ampere, and what would be the power factor? 15,000 by 400, 1000 by 400 cos 5 kilowatt. Okay, it's not 15 kilowatt, so 5 kilowatt. Sorry beta ji, kindly do the correction here. It's a 5 kilowatt, not 15 kilowatt. Okay, 5 kilowatt. So this is your 5 kilowatt. Okay, so 5 kilowatt by 15 by 400 cos inverse, answer is your 33.55, 33.557. So you know about the power factor angle. Current is 15, angle is minus of 33.55 into R equivalent is 0.25 plus of J5. Okay, now you can do the calculation for V2 dash. Once you have V2, you can refer it on the 100 volt side. You will get the answer. So 15 angle minus of answer. Why I am taking minus? Because in the question itself it is given that it is supplying lagging power factor load. So in the question it is given that while supplying lagging power factor load, okay, into 0.25 plus of 5y 400 minus answer. So this will give you 360.517 angle 9.64 and into 100 by 400, magnitude will become 90.129 amp volt. So instead of 100 volt under the operating condition, we are getting 9.12. 90.129. 90.129 is 90.13. So we have one option, 90.13. How many of you able to understand this question perfectly, beta ji? Yeah, okay, done. It's okay. 90.7 is also correct because there is only one option which is closer to 90, and the reason behind this is one may opt a per unit method, one may opt this method. So it doesn't matter because you will get only one option nearby. Okay, so how you are calculating based on that, our calculation approximation will be there, but okay, only one option which is near to 90. Can you solve this one? Can you solve this one? So see, I have kept this 20 question with a 20 different way, and it contains lot of formulas along with your concept recall. So these 20 questions are very important. I have tried to cover the entire in these super 20 questions. Hoping you are able to, sir, by changing the per unit method. No, there is no issue. You can go with the per unit as well. You will get nearby 90 only. Okay, and that all because of the calculation. Okay, because the calculation differences. Okay, calculation approximation there would be a little change. but you must need to be remember about the loading factor, because your transformer secondary side is not on full load. Okay, so that need to be considered here. If you are going with R per unit, X per unit, then that loading factor, full load current, and under this condition what would be the current I2 dash, the difference of that need to be considered well. Okay, now come to this one. Starting torque of 80 Newton meter is developed in an induction motor by an auto transformer starter. So starting torque by full load torque in case of an auto transformer starting is 3 by omega sm, no, that is is x square times of ISC by IFL square into SFL. Is it okay? Yes, sir. And if we are going to change the tapping only, rest of the thing we are not changing. So starting torque is proportional to x square, and x is the tap position. So starting torque new with the starting torque old ratio, all the constants get cancelled. So x is the tapping. Tapping of auto transformer is 70. Previously, the starting torque of 80 Newton meter with a tapping of 30%. With a tapping of 30%. Okay. If the tapping of auto transformer is now 70%, so tapping 70% of the winding is common now. Okay. So if 70% of the winding is common now, previously 30% of the winding is common. So square of this, and the old torque is 40. So can you calculate the new starting torque? Can you calculate the new starting torque? 435 is okay. Yes, it increases, beta. If we are increasing the supply voltage, definitely it increases. Previously the tap is on 30%, and now the tap is increased to 70%. Okay, so 0.7 by 0.3 square of this into 40. Yes, .7 by 0.3 square of this into 80 Newton meter, huh? Not 40, that is 80, na? Yes, 435.55 is okay. Previous is 80, na? Yes. 93.6 volt. Mohit, maybe you are in the previous question, huh? How many of you able to understand up to this part? So I am giving one question to you as a homework. I can solve it, it's just a 1 second question, but I am giving you as a homework, and I want you to share your solution over my Telegram, that is Varun sir PW. So you need to share your answer over the Telegram, and this Telegram group is for all of you. Okay, so it would help you if anything with the electrical, machine, digital, anything with the core subjects, and you want to discuss before exam, please feel free to connect over the Telegram. Okay, sir, video lag ho gaya tha. Now it is okay. Great. So hoping you have enjoyed this session a lot. So I'm giving this one as a homework to you. Hoping all of you have enjoyed this a lot. One more thing. Just a minute. So there are 2 more Telegram link which you can join for your further information related to any topic going on. That is your main channel, official channel, for any update based on your exams and all, and your ECEE group, so that you can connect it with the other teachers as well. Okay, sir. Okay, sir, will be available there na? Yes, I will be available. See, my some lectures are going on, but still now whatsoever question need to be reply, I am going through the Telegram on daily basis, and whatever question is need to be a reply, I am doing directly. Okay. If you feel like you need to answer instead of group directly, so you have an opportunity. You can connect over this and you can paste your option or anything, any problem separately also over the Telegram. Okay. So thank you everyone. Hoping you have enjoyed this session a lot. Sir, real test solution. Okay. Real test solution will be uploaded very soon. Thank you everyone. Lots of love. Hoping you have enjoyed this session a lot. And thank you once again. Best of luck for your exam. Try to revise as much as possible. Thank you everyone.